Okay, once again, folks, welcome to the second problem centered around momentum. So have a look at this problem. Three particles A, B, and C of masses 5 kilogram, 1 kilogram, and 2 kilogram respectively. They lie at rest in that order. So we might need to have a sketch of what we're seeing there. We have particles A, B, and C, and each of them is having a mass of here we have 5 kilogram, 1 kilogram, and 2 kilograms. So we are told that they are lying in the track XYZ. So I can bring the points X, Y, and Z. And then we are told that particle A is projected towards B with a speed 6 meters per second. Let me scroll up so that we have enough space. And at the same instance, C is projected towards V with a speed of V meters per second. In the subsequent motion, A collides and coalesces with B to form particle D. So let's raise up and say, when these two meet, they give us D now. And we assume D will move in the same direction since B was stationary. Then particle D then collides and coalesces with particle C to form particle E, which move towards Z. So when the collision happens, well, let's push down a bit. When the final collision happens, we can say somewhere here, then we have this particle moving towards position Z. So show that after the second collision, the speed of E is 15 meters per second. So we're going to have two collisions. And then let's have a look at what's happening there. And these two, when they collide, according to conservation of momentum, we have M1, sorry, U1. Let me erase this, pick my rubber there. All right. We have M1, U1 plus M2, U2. This will be equal to M1 V1 plus M2 V2. Then what do we know? It's only this one where we have 6 multiplied by 5. But because this is stationary, we have 0. Then when they are coalesced, we have a combination of the masses. There is 6 multiplied by the new speed that they'll be having as a particle D. And when we simplify, it looks like for that section, V will be 5 meters per second. So assume that here the object will now be moving at 5 meters per second. But now the combined mass here is going to be 6 kilograms. Now, as this one is coming, I think it's having a mass of 2 and a speed of v. So let's see what happens, because you're interested in what happens afterwards there. So I'm going to just change colors to represent the new speed that these objects will be moving as they move as unit E. So according to conservation of momentum again, we are going to have this product giving us 6 times 5. So that's 6 times 5 approaching, well, this direction there is coming this way. So that's 2 multiplied by V. And this will be equal to, when we combine everything, I'm sure the total masses is now going to be 5 plus 2 plus 1. It will give us 8. And then I say the new speed V, I'll bring it in a new color. So I want to make the new speed a subject of formula because that's what I want to uh, work with. So if I divide both sides by 8, here it cancels. Then I have my new speed V, which I want to confirm, and there will be 3 times 5, that's actually 15 minus V all over 4 meters per second. Let's check if that's what we're supposed to confirm. I think that's it, so we've confirmed the first part. Now, the total loss of kinetic energy of the system due to the two collisions is 63 joules. Now, we're interested in showing that our speed V of the system, I mean, it's 3. So let's try and have a look. When we say um, loss in kinetic energy, we are saying final kinetic energy. I think we need a formula there, that kinetic energy final minus kinetic energy initial. We are told that delta KE is negative 63. So final kinetic energy, I think for the whole system we had that. So it will be the formula for kinetic energy. We know if we want kinetic energy, This is half mv squared. And when I do my substitution for the final, well, the whole system has got a total mass of 8. So I'm going to say half multiplied by 8 multiplied by this speed that we confirmed that that was the final speed. So inside the brackets, I have 15 minus v all over 4, but this is squared. Then it's, well, that's the final. So we then say minus the initial. But the initial, we had two components in motion. These components were the first object which was moving, which was a particle, and was it X? Let's see. We call it particle A with a mass of 5 kilograms and moving at 6 meters per second. So we can come here and say for the first object it was a half multiplied by the mass which was 5 multiplied by 6 squared. And also the last particle which had a mass of 2. So it will be a half multiplied by 2 multiplied by it was v, which was its speed. Then this has to be squared. And we are saying this is equal to negative 63. So when we simplify, here we cancel and have a 4. And remember, when we square, one of the 4's will remain. So it will be 15 minus v all squared over 4 minus, so let's check what happens inside the brackets. Inside the brackets, I'll be having 6 squared, 36 times 5, that's 180 over 2. Sure, that will give us 90. That's this part. And there, when we simplify, it's plus v squared, because these two, they will cancel. And we are saying all this is equal to negative 63. And still moving with the calculation, we are saying we'll end up having just this expansion binomial. And when we multiply throughout by 4, so we open the brackets here, is minus 90 times 4, that's minus 360. Then when we do the same there, we get minus 4v squared equal to, let me bring my calculator for 63 times 4. So 63 times 4, it gives me 252. So this will be minus 252. Then if I open the brackets here, I'll have 15 squared, that's 225, and these two double is minus 30v, and when I square this, it gives me positive v squared minus 360. We are now here minus 4v squared. We are saying this is minus 252. I want to put my equation in standard form and see if I can factorize. Let's try and have a look. Um, these are like terms, so they'll end up giving us minus 3v squared. And when I move to terms with v, it looks like I have minus 30v there, so it will simply be minus 30v. Let me deal with the numbers now. So if I bring my calculator, the numbers that I want to target is 225, 225 minus, there's 360 there, 360. But remember, when we transpose negative 252, it becomes positive 252, giving us 117. So that's plus 117. This will be equal to 0. Now, we want to equate all to, I mean, we can simplify here. Let's try with negative 3 so that our coefficient here is positive 1. So we are dividing throughout, that will be plus 10v, and when we divide 117 by negative 3, so it's 117 divided by 3, we know it will give us negative 39. That will be equal to 0. So factors of 39, we have got 3 and 13, but remember this is negative and the central part is positive. So we are going to have it this way, where we have v, 1 is 10, 1 is 3. Oh, 1 is 13, sorry. 1 is 13, the other one is 3. And then we want the sum to give us 10 when 1 is negative. So it means negative goes to the smaller one. So in essence, this is denied because the object is not changing direction. So our v is actually 3 meters per second. And so that's what we're required to show. So we've shown that our speed v is 3 meters per second. So it is given that the distance xy is 36, and so we have x, y, z. So there the distance is 36 meters, and there is 98 meters. Um, then find the time between the two collisions. So the first collision, it happens after 6 seconds, because the object A was moving at 6 meters per second. So in essence, to move through this distance, it needs 6 seconds. When we divide distance by speed, we get time. But remember, this object will be moving at speed v, which we have found to be 3 meters per second. So if it moves at 3 meters per second, there's a distance that it's going to cover in these 6 seconds. So it's 3 meters per second for object C moving this way. So in essence, within 6 seconds, it will have traveled 6 times 3, which is 18 meters. So in 18 meters, object A will be there. And when we look at the difference between these two, I'm sure it gives us 80 meters. So it will have covered 80 meters when these two collide. Then our interest now is how long does it take for these two to collide? But what we know is one of them we have covered, I don't know, from this distance, 80 meters. One will cover h, maybe if h is going there, and this side, I'm sure it's going to be 80 minus h. And that time they take to collide, which is the second collision, find between the time between two collisions. So the time t will be equal to t. Then the question is, uh, at this point, do we know the speed of the uh, object which is coalesced? Because if we know the speed, it means we have the initial speed there. And after they've moved that point, I think we also have the, the speed. These surfaces, they are smooth, implying that if we say speed times time, it will give us distance. And even here, speed times time gives us distance. So 6 times 3 meters per second. So there is no collision at 80 meters. So it means the speed is still 3. And here where they coalesced, I think we got the speed up there. So let's check up there. Um, that when the two coalesced, show that after the second. But what about the first collision? The first collision gave us a speed of 5 meters per second. So it means after they collide, they were moving at 5 meters per second. 5 meters per second. So from this point, the combined system is moving at 5 meters per second. So what do we do? If we say 5 meters per second times the time t gives us h, so I'm allowed to come and say, well, 5 times t is equal to h, because the time that it takes for them to collide, it will be the same. That's for this coalesced object. Then for the second part, it's going to be 80 minus h being equal to is 3 multiplied by t. So let's try and eliminate h so that we find the time it takes for them to collide. Then we are going to say, if we put them in line, we are saying there is 80 minus h equal to 3t. And when we sum in line, it gives us 8t, and this they will go away equal to 8. So the time t is actually 10 seconds. So it looks like it takes 10 seconds for the two collisions to happen. Then 10 seconds, let's have a look. at the next problem, because the 10 seconds are the times that they take for those two to collide. But those 10 seconds, I think they would assist us in finding the distance that will be covered. Let me have the distance in red to say in the 10 seconds after object D is moving, how long will it have moved? We are saying it's moving at 5 meters per second as a combined system. It moves for 10 seconds. It means the distance covered before they collide is going to be 50 meters, because it's 10 times 5. So it means out of this 80, if we remove 50, we'll remain with the 30. So this will have moved 50 meters. Then they collide to form object E. So going this way now is now 30 plus 48. So whatever we do below, we are left with 48 meters to be covered. 48 meters to be 48 meters to be covered. Find the time between the instant that A is projected from X and the instant that E reaches Z. So what we have seen is in the first section or in the first collision, A moves 6 seconds. Then when we look at G moved 10 seconds before they coalesce. Now, when they coalesce, we managed to prove above there that the speed after coalition, which is E, because we need E, there is particle A there. And E, we say it is 15 minus V over 4. 15 minus V. I think we can prove it somewhere. Um, yeah, we proved it that 15 minus V over 4, that will be the new speed of the combined system. So then what do we do with it to help us to find the last section? So we know from E to reach the end, sorry, E to reach the end, we have, because we want E to reach the end. For E to reach the end, we are going to have a speed of 15 minus V, but V we saw that is 3 over. So it's more like the whole system, this system will be moving at 3 meters per second. But it needs to cover a distance of 48 meters from our calculation. So now if we divide the two, they give us time. So if I add here, it gives me 16 seconds. So for A to reach point uh, or point Z, I don't know where C was, A to move all this way, it needs 6 plus 10 plus 16. So in other words, the total time T is going to be 32 seconds for the object to reach the end. I think that's it on the second series of momentum. I hope you guys, you found one or two interesting things there. We'll meet in the last part where we'll discuss another problem again. Thank you.